This is Mr. Anderson for Kellogg Community College, and what we're going to do today is we are going to take a look at deriving in this video the double angle formulas and the half angle formulas. And this is not going to actually do any of the problems from this section, but it will just go through the proofs that tell us how we can get the formulas that we need. Now, the first thing we're going to do is let's review three of our alpha beta formulas from adding and subtracting angles. So for example, let's review when we have the sine of alpha plus beta, so that when we added two angles together, this was equivalent to the expression of sine of alpha cosine beta plus cosine alpha sine beta. Cosine of alpha plus beta was cosine alpha cosine beta minus sine alpha sine of beta. Tangent of alpha plus beta was tangent alpha plus tangent beta divided by 1 minus tangent alpha tangent beta. So all of these formulas had alpha beta in common in its setup. And again, there are some you can see that this first equation is sine cosine cosine sine. The symbols match. This is cosine cosine sine sine. The symbols do not match. And here the numerator is tangent alpha beta, like you see it with the sign matching. The denominator is 1 minus alpha beta tangent beta. So there were like tricks that we used to learn these. But what we're going to do in our first section here, which is going to be Chapter 3, Section 6, is we're going to learn about the double angle and half angle formulas. Now, when we talk about a double angle, we literally mean doubling an angle. So instead of us having the sine of theta, when we want a double angle, we're just wanting 2 theta. Cosine would then be 2 theta because we're doubling the angle, and then tangent would also be 2 theta because we're doubling the angle. So let's actually go through these systematically and see what they would become. I'm going to start off with sine. Let me quickly change colors here, just so I can keep all of these kind of separate here. So we're going to look at sine of alpha plus beta, but in this case we're going to look at sine of theta plus theta, because doubling an angle is the same thing as saying the angle plus itself. So what we can do is we can come up with the sine of 2 theta formula by just rewriting this as sine of theta plus theta and using a formula we already know from the previous unit. So this will become sine of alpha, or sorry, instead of sine of alpha cosine beta, this will become sine of theta cosine theta plus cosine theta sine of theta. Now, using the commutative property, I can rewrite this right side. Instead of writing it as cosine sine, I'm going to write it as sine cosine. So I now have sine theta cosine theta cosine theta, which then simplifies to 2 of sine thetas cosine thetas. So that is the equivalent equation, or equivalent expression. When you want to double an angle, you take twice the product of sine theta cosine theta. All right, let's actually now derive the cosine. And we're going to take this and write it as cosine theta plus theta. So we're going to take this formula, and instead of writing it as cosine alpha and cosine beta and sine alpha sine beta, we're going to write this as cosine of theta cosine theta minus sine theta sine theta. Now, you can see that that is going to make cosine squared theta, because that is going to be cosine and cosine, makes cosine squared, and then the sine squared theta there. Now, this is one of the formulas for cosine of 2 theta. There are also 2 other formulas for cosine of 2 theta, and we will derive those when we get to the bottom of this page here. But now let's do tangent, since we're on that right there. And let me take tangent. This is going to be the tangent of theta plus theta. All right. Sorry, just got to click on something here. Okay. So, with some room off to the side here, I'm going to go tangent. So instead of writing tangent alpha plus tangent beta minus tangent alpha, 1 minus tangent alpha tangent beta, I'm going to write tangent theta plus tangent theta. Sorry, that's plus tangent theta. I know that looks a little bad. And then 1 minus tangent theta, tangent theta. Well, the numerator will be quickly simplified. Tangent theta plus tangent theta is 2 tangent theta. And the denominator is 1 minus tangent squared theta. Now, what I'm about to do is I'm about to derive the other 2 cosine functions. Looks like I'm having some trouble drawing here. Figure out why the pen is stuck here. All right. You can edit that out. Okay. So, what I have here then, let me get my blue. What I have here then are my double angle formulas or the double angle trig statement, and that will get me to my double angle formula. So here's what we found. We found out that the sine of 2 theta is equivalent to 2 sine theta cosine theta. Our cosine of 2 theta is equivalent to cosine squared theta minus sine squared theta. There are 2 other cosine double angle formulas, and I will derive those because we need those to actually prove our half angle formulas. This is the one that you'll remember for the test because it's probably the easiest one to memorize of these 3 that I'm about to present. But again, seeing the other 2 ways to do this isn't going to be a big stretch. And the tangent of 2 theta is equal to 2 tangent theta over 1 minus tangent squared theta. Now, let's derive the cosine 2 theta formulas separately here. Now, we do need to begin with the cosine squared theta minus sine squared theta formula, because there's 2 different directions we can go from there. What I'm going to do is take this and change it to a different color. And what if I took the cosine squared theta and changed that into 1 minus sine squared theta, because that is a basic trigonometric property, and then continued simplifying with my negative sine squared theta. And that would give me 1 minus 2 sine squared theta. Now, that's one of my 2 additional equivalencies to the cosine of 2 theta. I will use this as a springboard for one of my proofs on the second side to talk about the half angle formulas. Now let me change colors one more time. And let's say I start off with the formula of my cosine squared theta minus sine squared theta, but I rewrite sine squared theta in terms of cosine. So this would be then become cosine of 2, or cosine squared theta, minus, now this is in parentheses here, 1 minus cosine squared theta, because this is an equivalency from our Pythagorean theorem trigonometric identity. Now, if I distribute the negative here, I got cosine squared theta minus 1 plus cosine squared theta. And most books rewrite this with the cosines in front. Cosine squared theta and cosine squared theta is 2 cosine, started with a s there, cosine squared theta minus 1. So this, 2 cosine squared theta minus 1, this is another equivalency or property of our double angle formula for cosine. So again, for the test, I would memorize this one. But if there was ever a need where you needed to do the problem without both sine and cosine in your answer, you can do that conversion pretty quickly. Now what I'm about to do is go through the half angle formulas, and again, this will finish our video, but this is only supposed to show you the different formulas we have for these two problems here, and it's not going to actually do any of the homework problems themselves. And we'll have our little formulas here at the bottom, and we'll do our little work here at the top. Alright, we're going to start off with the equivalency from the previous page, which is the cosine of 2 theta is equal to 1 minus 2 sine squared theta. Now what I'm going to do is I'm going to get sine squared theta all by itself. So to do so, I'm going to subtract 1 from both sides. So by subtracting 1 from both sides, I now have 1. Hold on a moment here. I got negative 1 plus cosine of 2 theta, and this is equal to negative 2 sine squared theta. Now the next thing I'm going to do is I'm going to divide both sides by negative 2. If I divide both sides by negative 2, what I then have is negative 1 plus cosine of 2 theta divided by negative 2 equals sine squared theta. Now to make this problem a little easier on me, I'm going to factor out a negative 1 from the numerator and the denominator. So if I do so, that would make the numerator 1 minus cosine 2 theta, and the denominator would be positive. By factoring out a negative 1 and then dividing it in the denominator, I turn that denominator into a positive 2, and this numerator becomes opposite of what it once was. Now, what I'm almost done with now is I'm going to get sine of theta by itself, so I'm going to take the square root of both sides. In doing so, this is going to be plus or minus the square root of 1 minus cosine of 2 theta divided by 2. Now, what's interesting about this setup here is that this will allow me to do the half angle formula. Now, a half angle formula is when we take a theta and we just take that theta and we divide it by 2. So, just taking anything, any like 90 degree, 120 degrees, but see most of those are on the unit circle already, but if we take a weird one like an 80 degree angle or something like that, we can use these half angles to get to something that we need. Now look at how it changes the formula. Plus or minus the square root of 1 minus cosine of theta divided by 2. So my half angle formulas are created by getting my problem here all by itself, and then just using this simple process here to divide by 2, and then we get our theta by itself. So there's our proof for the sine of theta over 2. So that's one of our identities right there. Now we're going to start off with the other thing we had on the previous page, that the cosine of 2 theta is equal to 2 cosine squared theta minus 1. Now what we're about to do here is we're about to get this cosine squared theta by itself. So I'm going to subtract 1 from both sides. So this is cosine of 2 theta minus 1 equals 2 cosine squared theta. I am going to divide by 2. So dividing both sides by 2, I now have cosine 2 theta minus 1 divided by 2. And I am then going to set this equal to cosine of 2 theta. All right, let me see here. Oh, actually I made a little mistake here. That should be a plus 1, so let me put the plus 1 there. Because I had to add 1 to both sides. So I'm sorry about that little mistake. So now I take the square root of both sides. So this is plus or minus the square root. And most books will rewrite this so it looks a little similar to the one on the left-hand side here. So this is 1 plus cosine of 2 theta divided by 2 equals cosine of theta. Now again, we're going to find our half angle formula. So we're going to take cosine of theta over 2 and change this to theta divided by 2, and 2 theta divided by 2 is just theta. So this is our half angle formula for cosine. You'll notice, look at these formulas, they're so similar. Now, what's important about these two is that you have to pick the plus or minus, and that will all depend on what quadrant you're in. Alright, now the final one we're going to do is we're going to do tangent. And I think I got enough room to squeeze it onto this side of the page right here. And how we're going to start off with tangent is we're going to start off with just this idea that tangent squared theta is equal to sine squared theta over cosine squared theta. Tangent squared theta is equal to sine squared theta over cosine squared theta. Now, we know that sine squared theta, from this formula over here, you see how if I'm going to put a little colored marker on this here, let's see, you see how this is sine squared theta? Well, there's sine squared theta right there. And cosine squared theta, since we've done these proofs here, it's pretty easy to see where this is coming from. Here's cosine squared theta right there. So tangent squared theta is going to be this blue writing divided by this blue writing. So let's actually get the writing out, but I'm going to do so in a red pen. So this is tangent squared theta is equivalent to this, and I'm going to use the simplified version here, this 1 minus cosine of 2 theta divided by 2, divided by, and I'm going to use multiplication instead. So it would be divided by this, but instead I'm going to multiply by its reciprocal. So the 2 is going to be on top, and this is going to be 1 plus cosine of 2 theta. And then multiplication works out that way. So these simplify. So my numerator is 1 minus cosine of 2 theta, and my denominator is 1 plus cosine of 2 theta. And what we have here is tangent squared theta is equal to that. To get down to our tangent, we're going to take the square root of both sides. So this is plus or minus the square root of 1 minus cosine 2 theta and 1 plus cosine of 2 theta. And then we substitute, instead of theta, we substitute our theta divided by 2 because we're going to do our half angle formula. This is going to be equal to plus or minus the square root of 1 minus cosine theta and 1 plus cosine of theta. Now, when we get to the bottom of this worksheet here and write down all the formulas, you're going to notice that we probably won't use this one because of the plus minus and the possibility of making a mistake. So let's go down and just rewrite all these formulas here so we have them, and that will conclude our video here of proving how we get each kind of our half angle formulas. So here's, and I'm going to put this above here, here's our half angle trig here. Our half angle trig, so we've got sine of alpha divided by 2, cosine of alpha divided by 2. We could also use theta. Tangent of alpha divided by 2. And we're going to have others for tangent as well. There's going to be 2 of them. So the sign from up above was plus or minus the square root of 1 minus cosine alpha divided by 2. This is going to be, cosine is going to be the same thing, except there's going to be a plus instead of a minus. Now the tangent, the one we learned, was plus or minus the square root of 1 minus cosine theta, or alpha in this case, sorry, and 1 plus cosine alpha. Now, a quick way to remember this third formula, if you know the first two, tangent is sine over cosine, so that's why this top one gets put over the bottom one, minus and minus. Obviously, you can think about how the properties would work there too when you multiply them. Now, there are 2 other tangent formulas, and these are derived in the book, and I will not do those for this video here. But 1 minus cosine theta divided by sine of theta is one of those 2 formulas, and conversely, sine of theta over 1 plus cosine of alpha. I kept saying theta, I'm sorry about that, but according to my formulas over here, I used alpha. So sine of alpha over 1 plus cosine alpha, it really depends on how complex you want your problem to be, but I found that most of the time students prefer one of these 2 methods, especially when we have to rationalize a denominator with a radical. There's a lot of help to be used with one of these 2. So I would suggest memorizing one of these 2, your choice, and then these 2 here. And that, my friends, gets us through the proofs of our half angle and double angle formulas. The next video, we'll actually get into some problems covering the lesson. Thank you for watching.